आते आज लेते भाग जाते मोबाइल पर टाइप नहीं होता कि 1 मिनट की खबर है ना मतलब हो गया 3 बार आया हो आप आपके लिए किसने कहा आपने कहा साहब चला गया पहले आते हो देर में उन्होंने पूरी दफ्तर की कहानी ऐसे कर लो 15 दिन का शेड्यूल बनाया 15 दिन का मिलकर कोशिश करेंगे सेटअप होने में टाइम तो लगेगा तारीख को आ जाती हो जाएगी ऐसा नहीं 31 तारीख को आ जाती तो फंडी में हमारी दरकार नहीं है तब दरकार नहीं है पहली बार आरसी वन बोलने वाला नहीं करनी फंडी में आएगा कल ही आना पड़ेगा पहली बार ऐसा हुआ कि 1 तारीख को पहली बार मैं कुछ देखूँ मैंने क्लास में दिया 1 तारीख को आ जाती सर नमस्कार बात नहीं मैं वो लिस्ट निकाल कर रखा हूँ परसों वाली Good morning, learners and viewers. Welcome to the session for quantitative analysis for managerial application, MMPC 005. We will start with block 1, that is data collection and analysis. It comprises of 4 units: collection of data, presentation of data, measure of central tendency, measure of variation in students. We will start with collection of data. Facts expressed in quantitative form can be termed as data. Success of any statistical investigation depends on the availability of accurate and reliable data. This depends on the appropriateness of the method chosen for data collection. That is why data collection is very basic activity in decision making. There are 2 types of data: primary data and secondary. If we talk about primary data, when the data is collected specifically for the objective of the study under the control and supervision of the investigation for the very first time. Whereas secondary data is when the data is not collected specifically for the objectives of the study, rather derived from records, registers, journals, reports, theses, etc., which have been already published. What are the different methods of primary data collection? First one is observation method, and the second one is questionnaire. As far as observation method is concerned, here, investigator asks number of questions. He only observes and records. For example, recording of number of health service providers, retail outlets in a locality, educational institutions in a particular place, etc. Accuracy of data is difficult. Error in recording or observation due to physical barriers or difficulties. If you talk in terms of questionnaire method, it is more widely used method in marketing and social developmental research. And it is done through preparation of questionnaire, incorporating questions relevant to the objectives of the study, administration of the questionnaire, and through personal interviews by mail or telephone. If we talk about personal interviews, here investigator is in direct contact with the respondent. The information gathered is more accurate, reliable, cross-checking and clarification of doubts is possible, And a fine tuning is generated between the investigator and the respondent. No doubt, it has some demerits. It is a time consuming process, costly affair because you have to allocate a person. Here, he will be an investigator, and large number of respondents are widely distributed throughout. Second part is male questionnaires. Again, the same thing is there. There is an investigator and a respondent is there. What is the requirement? If we send a questionnaire to a respondent, the respondent must be literate. He should have an ability to understand instructions and questions and then answer them. It is easily adopted when when the geographical area is large and respondents are widely spread. In case of telephone, we have a requirement of phone facility. Merit is it's less expensive and we can get an instant response from the respondent. And at a time, we have an advantage of connecting 3 or 4 people at a time. Again, it has some demands, less number of users. People get irritated when a telecaller makes a call because he or she is asking a question related to the services what they have provided. And we have limited number of respondents. As far as this questionnaire method is concerned, it has a serious limitation. It's difficult in obtaining the information on ethical and sensitive issues. For example, income, disease history, personal life detail. Nobody is interested to discuss or to tell the personal income or if he or she is suffering from any disease or anything which is related to their personal life. That means name of the wife, respondent or spouse, name of the children, their age, respectively. This part is basically avoided in the questionnaire method. There is chances of errors and fallacies in recording of responses due to the variation in understanding of respondents and investigators and interpretation done by may be wrong. How to design and how design of surveys it is designing of a questionnaire, retesting of a questionnaire, and editing the primary data. These are the sequences which are followed in data collection. If we talk about how the designing of questionnaire is done, first of all, it should have covering letter, it should have introduction, objectives, instructions, and consent. We have to keep in mind about the number of questions to be asked. We should have minimum number of questions and maximum output can be done. So that while framing up the questionnaire, questions should be simple, short, and ambiguous. We should avoid ethical, sensitive, or personal questions. No calculations, logically arranged, should be there, and we have to cross checks and footnotes. If the second part is pre-testing a questionnaire, we have to do a pilot survey. In that case, a rectification plays an important role, which generates a problem. It may be inconsistencies will be there and repetition of the answers may be there. So we have to keep that thing into consideration. This helps us for suitable changes, deletion of irrelevant questions, inclusion of checks and instructions, and assessment of time in administration of the questions and the answers have to be can be monitored. While we have obtained the primary data. Then comes editing of primary data. We should have completeness of the information. That means we have to see that all questions, that is, each and every question has been answered. Consistency, the responses should not be contradictory. Accuracy, you have to check for accuracy of obtained information. And for checking inaccuracies, random cross checks can be. We have different softwares with normally it is performed. Homogeneity also plays an important role. Understanding of questions should be seen in which they are to be perceived. That is, income, weekly, monthly, or annually. Ambiguous questions will provide irrelevant information if it is not related to the subject. What are the sources of secondary data? These are the sources of information that has been already published. If we talk about national organizations that are CSO, NSSO, Office of Registrar General of India, FIC, ICAR, etc., these are the organizations, national organizations which publish their data annually, monthly, weekly. It is available in public domain. Then comes international organizations, that is UN, WHO, ILO, IMF, World Bank, UNESCO, UNICEF. They all publish their data in for public domain. Then comes your unpublished sources. All statistical data need to be published. And major source for obtaining this secondary data is government and semi-government, private and public organizations, payrolls, cash books, transaction data, etc. What are the precautions which we have to take while using the secondary data? We should not accept the data at its face value. Now the question is why? Because data may be full of errors because of bias, inadequate sample size, non-representative and purposive sample, computational errors. We have to focus on what? Suitability of the data. Is the data suitable for the purpose of study, inquiry, that is just the nature and scope of the study? Reliability. We have to determine the reliability of the data and just the agency or the organization and unbiasedness. Proper data analysis has been done. Analysis has to be done. Credibility, whether data provides entire gamut of information or a part of information under the study. Data collection through original investigation. When secondary data is not available for the problem under study, a discussion or a decision of primary data collection through the original investigation is suitable in that case. The two types of methods that are available for data collection are Celsius, that is complete enumeration method, and the second one is sampling method. We start with what is Celsius method. It is a complete enumeration of the data. When investigator collects data by covering each and every unit of the total population, this method is known as complete enumeration or Celsius method. For example, all males and females, all males or all females or all children, all households or all business or agencies, all retail outlets or dealers or population as the required data is required. Celsius method has merits and demerits both. Merit is that we get the information about each and every unit. It is more accurate, real, and consistent. But it has some demerits also. Economically, it's not viable. It is time consuming, time taking, and quality may suffer, notating or collecting the data. Now, the thing is that what is meant by sample? When an investigator collects data by covering only a representative part of the total population and make inferences about the total population. This method is known as sampling method. It has merits. It is a representative of the entire population. It is time saving and it yields correct inferences. Now, in Unit 1, we have seen that we have collected the data. Now, how the data is presented. After data collection, data needs to be used properly. For this, data should be arranged, displayed, and summarized in the appropriate manner. The presentation of data can be done by following. Data can be displayed either in tabular form or through charts. For tabular form, data needs to be classified before it is tabulated. That means classification of data, charting of data. What are the objectives of classification? We condense the mass of the data so that the salient features can be noticed. It facilitates comparison between attributes and variables. We can prepare data to be presented in tabular form, and it highlights the significant features of the data at a glance. What are the types of classification? They are basically of four types. The first one is geographic, chronological, qualitative, and quantitative. If we talk about geographical part, it is area, region, or place of the study. Chronological order, occurrence of the event. Qualitative, what are the attributes? And quantitative, it is in terms of magnitudes, numerical values. Now we refer to the examples. Production of rice country-wise. It is in the terms of geographical part. Sales figure of a company year-wise. That is chronological order. Classify population on the basis of education. That is qualitative. And the number of vehicles in city of Hyderabad. That is quantitative because it is related to a number. Now we will see different terms what are used in data presentation. We start with frequency distribution. It is an arrangement of data in groups or categories. Here, raw data is represented by distinct group, which is known as classes, and the number of observations that falls into each class is its frequency. Now, we see we'll talk in terms of discrete frequency distribution. First of all, we place all the data in the ascending order. You can see in the column number 1, that is number of children. Second column is number of families, and the third column is its frequency. We use telemarks to count the number. Now the thing is that how it is done. It is represented by 4 vertical lines and 1 cross line, which means a combination of 5 things. We can see if we talk for a family with number of children as 0, here we can see that there are 3 families, that means there is a frequency of 3. For 1 child, we have 8. For its representation, we have to draw 4 vertical lines, 1 inclined line, that is 5, then again 3 vertical lines. That means a total of 8. For number of children of 2, we have 2 vertical lines, that is its frequency is 2. And for 3, it is 1, and for 4, it's 0. This is how telemarks are drawn. What are the types of class interval? There are 3 types of class intervals. First one is exclusive method. For example, it starts from 20 to 25, 25 to 30. Inclusive method is 20 to 24.99, then 25 to 29.99. And open-ended is 30, for example, 30 and above. Normally we use exclusive method. What are the guidelines for choosing the class entrance? First of all, number of classes should be between 5 and 15. The width of the class should be simple like 5, 10, 25, etc. And the classes should have equal width. The starting point of the class should begin with 0, 5 or a multiple. Fifth one is class interval is found by dividing range by the number of classes. We will see by this problem. This is a data of 50 employees of an organization. Now, these are the ages. We can see that there are 50 observations. Now, we have to convert this data into a tabular form. So, first of all, we will find out the lowest number. The lowest number in this data, that is 21. As it was already told that it should have a multiple of 5 or 5, 10 or 15. Now we have to see that what is the highest value. The highest value, it is somewhere around 65. So we will decide to have class width of 10, 20 to 30, 30 to 40, 40 to 50, 50 to 60, and 60 to 70. That means age has been decided. Now comes, we have to calculate its frequency. For calculating the frequency, we have to use derivatives. So we will start with 22. 22 comes in the category of 20 to 30. So we will mark one vertical line. 21, it is again in that class. 37, 37 comes in the class of 30 to 40. We will mark one vertical line. 33 again comes in that part. 28 on the upper one. 42 will come in 40 to 50. 56 will come in 50 to 60. So we will mark one vertical line. 33 again in second. 32 again in second. 59 that will come in 50 to 60. We will draw one vertical line. Similarly, we will mark all. That means we will make tally marks. For 5 observations, we have to draw 4 vertical lines and 1 inclined line. So in that, we find that for the age group of 20 to 30, we have 7 people, 7 employees. And for age group of 30 to 40, we have 16. 40 to 50, we have 15. And 50 to 60, we have 9. And for 60 to 70, we have 3. When we are going to total them, it will come out to be 50. Now, what is cumulative and relative frequency? Two data will be given to us. That is monthly salary and number of employees. Number of employees is the frequency. Now, how to draw or how to calculate cumulative frequency? In first row, in front of 5, we will write 5. Then we will add 10 to 5, we will get 15. Then we will add 25 to 15, we will get 40. And to 40, we will add 10, we will get 50. We can see that the last term of the cumulative frequency column and the total number of frequency should be same. If there is any error or there difference is there, so we have to recalculate it. I'm repeating it because this is one of the most important things. For calculating cumulative frequency, we will write 5 in front of 5, and from the cumulative frequency column, that 5 will be added to column number 2. Row number 2, that is 10. So 5 plus 10 is 15. 15 plus 25, that is row number 3. That is 40. Row number 4, 40 plus 10, we will get 50. We see that cumulative frequencies last is 50 and the sum of the frequency is 50. Now comes how to calculate relative frequency. We will divide 5 by 50, 10 by 50, 25 by 50, 10 by 50. We get this relative frequency in decimal. And when we are going to add all this, we are going to get 1. This is how calculation is done and the correctness of our calculation is done. There are two important advantages in looking at relative frequency, that is percentages, instead of absolute frequency in a frequency distribution. Relative frequencies facilitate the comparison of two or more than two sets of data. Relative frequencies constitute the basis of understanding the concept of probability. Now, we move to data has been analyzed. Now we move to charting. Charting can be done through these 4 types. That is bar diagram, histogram, frequency polygon, ogive, or cumulative frequency curve. We start with bar charts. It can be simple, it can be 3-dimensional, or it can be stacked as the data is available or as what we want how to represent the data. For simple bar charts, it has demerits. The data is no longer available for further analysis. Analysis that is friendly, greater immediacy, that is pattern can be made easily visible with 3-dimensional or straight bar charts. Here we can see that this data is related to the number of years and the number of cells produced by a factory. Now comes your histogram. This is one of the most commonly used and easily understood method for graphical presentation of frequency distribution. A histogram is a series of rectangles having areas that are in same proportion as the frequencies of a frequency distribution. Then comes your frequency polygon. We have seen that a histogram has been drawn. Now what we are going to do? We are going to find out the center point of the top of each bar. Here you can see 15 center part, 22, 35, 30, 25, 20, 60, 70. We will join all these points, center point of the top of the histogram. We will get a curved line, and we will extend that line to your x-axis. If we are going to remove this histogram, so we are going to get something, a curve, something like this, and this is a frequency curve. Now we move to ogives or cumulative frequency curve. An ogive is the graphical representation of a cumulative frequency distribution, and therefore when the graph of such a distribution is drawn, it is called cumulative frequency curve or ogive. There are 2 methods for constructing ogive. First one is less than ogive, the second one is more than ogive. In less than ogive, the upper limit of various classes are taken on the x-axis, and the frequency is obtained by the process of cumulating the preceding frequency on the y-axis. That means this is a graph between cumulative frequency and the classes, which is taken on the x-axis. And in terms of more than ogive, this is again a cumulative frequency curve, which can be drawn from the lower limits on the x-axis and cumulative frequencies on the y-axis. Here you can see, on the y-axis we have cumulative frequency, and on the x-axis we have the class intervals. This less than ogive moves from bottom to top. On the other hand, the more than ogive starts from top to bottom. The shape of less than ogive curve would be a rising, whereas the shape of more than ogive should be a falling one. Now the thing is that when we are going to club these 2 diagrams, what we are going to get. When these two diagrams are added up, that means on a single graph, more than oxide and less than oxide is found. Where they meet, that point gives us the median. Now we move to unit 3, that is measure of central tendency. A statistical method for summarizing and describing data. We will find out one representative value which can be used to locate and summarize the entire set of varying values. We will find out central value around which the data tends to cluster. That means we are going to find out mean, median, and mode. What is its significance? It condenses the mass data to a single value. You get an idea of the entire data. That means if you find out the individual income of 1,000%, we are going to calculate their average income. If we are want to compare two or more sets of data, then we should have sales figure of August versus other months. What are the properties of good management? It should be easy to understand, simple to compute, it should be based on all the observations, uniquely defined, capable of algebraic treatment, and it is not affected by extreme values. Now, what are the important measures what we are going to study or what we should be aware of? First one is arithmetic. Second one, weighted arithmetic, median, quartiles, mode, geometric mean, and harmony. We will start with arithmetic mean. Mean is basically a sum of scores divided by number of scores. We can see that here the three formulas are depicted in the slide. Now, how they are used. If we are given with different numbers and we have to find out a mean, what we are going to do, we are going to sum up all the observations divided by the number of observations. That means we have to use formula number 1, that is x bar is equal to summation of x divided by n. Second formula is, you can see over there, it is fx, summation of fx. That means here a class interval or mid values or is given and we are having the frequency. In that case, we are going to multiply that mid values with the frequency and we have to sum them up and we have to divide by number of observations. The third formula is basically used when the frequency size is big. So there we use the formula x bar is equal to a plus summation fd upon n into I, where your d is equal to x minus a upon I. We will discuss this later during our discussion. Here, x bar is the population mean and n is the number of scores. A is in change of the origin and I is the change in the scale. What are the properties of arithmetic? The sum of the deviations of the observations from the arithmetic mean is always zero. Symbolically, summation of x minus x bar is always 0. And the sum of the square deviation, because x minus x bar is the deviation of the observations, the mean is minimum. The arithmetic mean has the great advantages of being easily computed and readily understood. It is due to the fact that possesses almost all the properties of the good measure of central tendency. No other measure of central tendency possesses so many properties. Again, we have some disadvantages. The major disadvantage is that its value may be distorted by the presence of extreme values in a given set of data. A minor disadvantage is when it is used for open-ended distribution, since it is difficult to assign a midpoint value to the open-end class. Now we see how the formula is used. I told that x bar is equal to a plus summation fd upon n into I. This formula will be used when the frequency numbers are too big. Here you can see we have 50, 52, 25. We will be given with two things: monthly sales, that is in rupees 1000, and number of firms, that is the frequency. We have to calculate the mid value. Now the question arises how this mid value is calculated. This is very simple: 300 plus 350 divided by 2. We get 650. 650 divided by 2 is 355. Similarly, we're not going to do it again and again. We will find out what is the difference between the class interval. We have a difference of 50. Simply, we will add 50 to 325. That means we are going to get 375. Again add 50, 425. Again add 50, 475. Similarly, 525, 575, 625, 675, and 725. We have three columns right now. Now, we will assign a value from the mid values, and we use a center value. Here we have used 525 as the center value. In the fourth column, we have to calculate D. That D is x minus 525 divided by the difference, that is 50. To make it easier and to make it simpler, we have assumed 525 as A. So similarly, in front of that column, we will write 0. Above it, minus 1, minus 2, minus 3, minus 4. And below 0, we will give 1, 2, 3, 4. Value you will be calculating individually, you will be getting the same thing. But to save time, we normally do minus 1, minus 2, minus 3, minus 4 above 0, and plus 1, plus 2, plus 3, plus 4 below 0. We will now calculate f into d. So we will multiply 5 by minus 4, that is minus 20. 14 by 3, 14 by minus 3, that is minus 42. Similarly, we will be calculating all the values and we will be adding. While we will be adding, we will be getting summation of FD, that is minus 60. Here, when we are going to add the frequencies, it is 200. That means N is 200. Now, we're going back to the formula. We have A, that is 525, summation of FD as minus 60. We have N, that is 200. Now the question arises, what is I? I is the class difference, that is 350 minus 300, that is 50. Now we will be calculating 525 minus 60 upon 200 into 50. So we are going to get 510. Now the thing is that going back to the question, we can see that central value will be somewhere around 5. It will be between 500 and 550. And our solution says that it is 510. That means we can assume that we have calculated the mean correctly. Now, we move to median. Median is basically the middle value of the distribution. Or rather, we can say that half the scores are above median and half the scores are below median. Median is less sensitive to extreme scores than the mean, and better measures the mean for highly skewed distribution. Here, the summation of x minus x bar is minimum about the median. Now, how to calculate median? Taking a broader term, if we have three observations, that is 247, and the number is odd. We have three values in it. What we will be doing, we will simply arrange this order in the ascending order. That means 247 will be there. And the mid value is 4. Now, when these observations are even in number, then the median is the mean of the two middle numbers. If we have 2, 4, 7, 12, here the observations are 4. What we are going to do, we will arrange them in the ascending order. It is the same thing, 2, 4, 7, 12. We can see that there are two values, 4 and 7. So we are going to add them. 4 plus 7 is 11. 11 divided by 2 is 5.5. That means we can say that here the median is 5.5. Now, if we have group data, that means we have data with frequency. There we use this formula. Median is equal to L plus n by 2 minus PCF upon F into I. L is the lower limit of the median class. N by 2 is the summation of frequency divided by 2 minus PCF it is the preceding cumulative frequency to the median class. F is the frequency of the median class, and I is the size of the median class. The class which has cumulative frequency just greater than n by 2 will be the median class. That means we have to first of all calculate n by 2, because in median we have already seen that 50% of the things are on the left side and 50% of the things are on the right side. That is why we are doing n by 2. Then comes mode. Mode is the most frequently occurring score in a distribution. It is greatly subject to a sample fluctuation and is therefore not recommended to be used as the only measure of central tendency. A further disadvantage of mode is that many distributions may have more than one mode. These distributions are called multimodal distributions. There is an empirical relation between mean, median, and mode. Mathematically, it is the difference between mean and mode is 3 times the difference between mean and median. So in general, we can say that mode is equal to 3 median minus 2 mean. If we have a question related to, or it consists of frequency in that, the modal, first of all, we have to identify the modal class. And modal class is that class which contains the highest frequency. Now we move to the formula for using or for calculating mode. That is, mode is equal to L plus the difference of F0 minus F1 upon 2 times of F0 minus F1 minus F2 into H. Now, what are these different F0, F1, F2, H, and L? L is the lower limit of the interval containing the mode. H is the width of the interval containing the mode. N is the number of the respondents, that is the summation of frequency. F1 is the frequency of the preceding modal class. F is the number of cases in the interval containing the mode. And F2 is the frequency of the class following the modal class. We will see how this is calculated. Here, I will take a problem and I will calculate mean, median, mode for you. The question is, during the conduct of a research study involving a group of 40 library staff, the following scores of the library aptitude test was obtained. We have to calculate mean, median, and mode. Now, we will convert that into class interval and frequency. This is basically what is given to us. 0 to 10 is 45, 10 to 20, 20, 20 to 30 is 14, 30 to 40 is 7, 40 to 50 is 3. When we are going to sum this, we are going to get 89. Now we have to calculate cumulative frequency. As it was told that cumulative frequency, for calculating cumulative frequency, we will refer to row number 2. We have a frequency of 45. So straight away in cumulative frequency column, we are going to write 45. We are going to add 20 to 45, we are going to get 65. Similarly, 65 plus 14 is 79. 79 plus 7 is 86. And 86 plus 3 is 89. Moving further, we will calculate mid values. Mid value is 0 plus 10 divided by 2. We are going to get 5. We can see a difference of 10. So straight away we are going to add 5 plus 10 is 15. 15 plus 10 is 25. 25 plus 10 is 35. 35 plus 10 is 45. We have to calculate fx, frequency into mid values. That is 45 into 5, 25. 20 into 15 is 300. Similarly, we will be calculating all these values of fx and we will be adding. We are going to get 1255. Now, since the highest frequency occurs in the first class interval, I'm going back to the problem. That is 40. We are talking about mode now. Maximum frequency is in 45, that is in the first class. Now, we will calculate mean and median. If we talk about calculating mean, it is summation of fx divided by summation of f. We have summation of fx as 1225 and summation of f is 89. We are going to get 14.10. Now, for calculating median, we have to use the formula L plus n by 2 minus Cf upon f into I. Here, 14.5 occurs in the first row. In that case, L will be 0. The difference I will be 10. We can see that L plus n by 2 minus Cf upon f into 10. That is 0 plus 45.5 minus 0 upon 45 into 10. This comes out to be 9.89. We have calculated mean and median. Now we know the empirical relation. That means mode is equal to 3 median minus 2. This is easier to calculate. We can find out mode as 1.47. Moving further, there comes quartiles. Quartile means division of data into 4 parts. That means the data is divided into 4 equal parts. Since 3 points divide the distribution into 4 parts, the first quartile is Q1. Here, the value is about 25% of the observations are smaller and 75% of the observations are larger. The second quartile is Q2 and it is the median. That means 50% of the observations are smaller and 50% of the observations are larger. Third one is the third quartile, that is Q3. It is the value such that 75% of the observations are smaller and 25% of the observations are larger. We have a formula, empirical formula for calculation of quartiles. That is quartile J is equal to L plus Jn by 4 minus PCF upon F into Y. This is almost similar to median. Then comes decile. That means decile means we will be dividing the data into 10 equal parts. Since 9 points divide the distribution into 10 parts. We will have 9 deciles, D1 to D9. Here, dk is equal to L plus kn by 10. We are dividing the data into 10 parts. That means divide by 10. Minus PCF upon F into I, where your k will be 1 to 9. Then comes percentile. Percentile means dividing the data into 100 equal parts. That means we will be having 99 parts. Here for percentile we will be using P1, P2, P3 till P99. And the formula will again be same. There will be a minus change in it. It will be PL is equal to L plus Ln by 100 minus PCF upon F into I, where L has the value from 1 to 99. Now, how to locate quadrates graphically? To locate median graphically, we have to draw less than cumulative frequency curve. That is less than or equal. We take the variables on the x-axis and the frequencies on the y-axis. We determine the value by locating n by 2th observation on the y-axis. We draw a horizontal line from this to the cumulative frequency curve, and from where it meets the curve, we draw a perpendicular line on the x-axis. That point where this line meets on the x-axis is the median value. If you remember, we have seen that less than curve and more than curve, where they intersect, that point is the median. Here we see how from a cumulative frequency curve, all these values are drawn. If we talk about Q1, that means 25% of the observations are equal. What we are going to do on the percentage ratio, we are going to find out 25, that is 0.25. We can get, we have drawn less than curve from the observation. Now from this graph, we have to calculate Q1, Q2, D2, D90. Now, this is Q1 means 25%, 0.25. We will locate on y-axis 0.25. We will draw a horizontal line. Where that line is going to meet the curve, we will draw a perpendicular line which will be meeting now on the x-axis. So there in the problem, you can see that this Q1 line intersects x-axis somewhere at 47.2. Now, Q2 is median. That is 50%. We will draw a horizontal line which will be meeting the curve, and from that point we will be drawing a perpendicular line which will be meeting on your x-axis. Here in this problem we can see that it comes out to be 56.67. D6, that means 60% of that. We will draw a horizontal line which will cut at the curve. We will draw a perpendicular line. Here we see that D6 comes out to be 60. And if we talk about P90, percentile 90, we will find out 90. We draw a horizontal line meeting the curve, draw a perpendicular line. There we get P90 is somewhere around 85. This is how we can calculate or we can find out percentile, decile, quadrille graphically. First of all, we have to draw a cumulative frequency curve. Now, going back, how to calculate mode. The mode is the typical or commonly observed value in the set of the data. It is defined as the value which occurs most often or with the greatest frequency. The dictionary meaning of term mode is most usual. We have a formula for that is mode equal to L plus D1 upon D1 plus D2 into I, where L is the lower limit of the model class, D1 is the difference between the frequency of the model class and the frequency of the preceding class, whereas D2 is the difference between the frequency of the model class and the frequency of the succeeding class, and I is the size of the model class. Now, how to locate mode graphically? In a group data, The value of mode can be determined graphically. In graphical method, the first step is to construct a histogram for the given data. The next step is to draw two straight lines diagonally on the inside of the model class bar, starting from each upper corner of the bar to the upper corner of the adjacent bar. The last step is to draw a perpendicular line from the intersection of the two diagonals lines which meets on x-axis, which gives the model value. Here it is. What this is the histogram which has been drawn. Maximum is for the maximum price 25. We can see there are two graphs, two bars adjacent to this. We are going to join the top corner diagonally to the next one, and from right top corner to left we were going to draw. Where these two lines are going to, we are going to draw a perpendicular line. So here we can see that mode is 35. That means we have calculated mode graphically. The chief advantage of the mode is that it is by definition the most representative value of the distribution. For example, when we talk of the model size of shoe or car, we have this average in mind. Like median, the value of mode is not affected by the extreme values and it can be determined in open-end distribution. The main disadvantage of the mode is it is intermediate value. That is, we cannot calculate its value precisely in a group data, but merely estimate it. When a given set of data have two or more than two values as maximum frequency, it is a case of bimodal or multimodal distribution, and the value of mode is not unique. The mode has two useful mathematical properties. Hence, in actual practice, the mode is important as a conceptual idea than as a working average. We will see now what is the relationship between mean, median, and mode. You can say that we know the empirical relation. Now we will see how this empirical relation is shown graphically. A distribution in which mean, median, and mode coincide is known as symmetrical or bell-shaped distribution. And if the distribution is skewed, that is, it is not symmetrical, then mean, median, and mode are not equal. The problem what we solved just a few minutes back, they were all having three different values. The mean was different, median was different, and the mode was different. That means that was an example of non-symmetrical or skewed data. In a moderately skewed distribution, a very interesting relationship exists among mean, median, and mode. In such type of distribution, it can be proved that the distance between mean and median is approximately one-third of the distance between mean and mode. What we saw while we were discussing mathematically, now it is in terms of distribution or it's in terms of graphical representation. Now we will see. Here you can see that there are two graphs, mean, mode, and median are different in both the cases. When we are going to find out a relationship between mean and median for this graph, so we will find it out that mean minus the difference between mean and median is one-third of the mean difference between mean and mode. So we can say that mode is equal to 3 median minus 2 mean, which is our empirical formula. Now comes geometric mean. The geometric mean is the average that is useful for set of numbers that are interpreted by their products and not their sums. That is, for example, rates of growth. Here, we are going to take the nth root of the number of observations, product of That means if you take an example that we have six values over here: 34, 27, 45, 55, 22, and 34. So for calculating the geometrical mean, we have to multiply all these and we have to take, because there are six observations. That means we have to calculate 1/6 root. It comes out to be, after the calculation, it comes out to be 34.545. When the number of observations is 3 or more, the task of computation becomes quite tedious. In that case, we will be taking the help of log. Therefore, a transformation into logarithm is useful to simplify calculation. If we take logarithms on both sides, then the formula of gm becomes gm log gm is equal to 1 by n into log x1 plus log x2 plus still log xn. And for calculating gm, we have to take the antilog of this calculation, that is my summation of log x upon n. For the group data, the geometric mean is calculated by the formula. That means geometric mean is equal to antilog of summation of f log x upon n, because there we are going to get frequency. Geometric mean is specifically useful in the construction of index numbers. It is an average more suitable when large weights have to be given to small values of observations and small weights to do large values of observation. This average is also useful in measuring growth of population. Then comes your harmonic mean. The harmonic mean is the average, which is useful for set of numbers which are defined in relation to some unit. That means speed, that is distance per unit time. So here the mathematical formula is x bar is equal to n upon summation of 1 upon xi. Going back to the problem, we can see that if we have the observation 34, 27, 45, 55, 22, and 34, there are six observations. Placing all these values in the formula, that is 6 divided by 1 upon 34, 27, 1 upon 34 plus 1 upon 27 plus 1 upon 45 plus 1 upon 55 plus 1 upon 22 plus 1 upon 34. While we will be calculating this, we are going to get 33.01, or we can say 33.11. The harmonic mean is useful for computing the average rate or increase of profits or average speed at which a journey can be performed, or the average price at which an article has been sold. Otherwise, its fields of application is very restricted. With this, we will be completing today's session.